Let's learn about compound inequalities. A compound inequality is two inequalities joined by either the word and or the word or. For example, this would be considered a compound inequality. And the way we solve compound inequalities is we work with each side separately. So let's start with this first inequality here. We can begin by subtracting 2 from each side. Which gives us 3x is less than or equal to negative 6, because 2 minus 2 is 0. Now dividing both sides by 3, and 3 is a positive number, so this inequality will not flip. It gives us x is less than or equal to negative 2. All right, what about this second inequality here? Again, we can begin by subtracting 4 from both sides. Which gives us 4x is greater than 20. Again, dividing gives us x is greater than 5. Now, because our inequalities are joined by the word or, our solution here will be all x values that make at least one of these inequalities true. So let's graph this. So here's 0. Let's say this is negative 2, and this is 5. All right, x less than or equal to negative 2. We put a closed circle at negative 2, and less than, we go to the left. X greater than 5. X cannot equal 5, so we put an open circle, and then greater than, we go to the right. Which would be our answer? All right, let's see another example. Now, although we don't see the word and or the word or here, this is still a compound inequality. In fact, it's a short way of writing the following. 15 is less than or equal to 3 minus 2x, and 3 minus 2x is less than 33. Again, we can solve each inequality separately. So let's begin by subtracting 3 from both sides, which gives us 15 minus 3 less than or equal to 3 minus 3 and then minus 2x. And 15 minus 3 is 12. So we have 12 less than or equal to negative 2x, because the 3's will cancel. So now let's divide both sides by negative 2. But we have to be careful here because we're dividing by a negative, which means this inequality will flip, which gives us negative 6 is greater than or equal to x. Or we can write it the other way, x less than or equal to negative 6. All right, what about this other inequality here? Again, we can subtract 3 from both sides, which gives us 3 minus 3 minus 2x less than 33 minus 3, or negative 2x less than 30. Again, divide both sides here by negative 2. And this inequality will flip, which gives us x is greater than negative 15. Now let's graph this. Here is negative 15, and here is negative 6. So less than or equal to negative 6, x can equal negative 6, and then we go to the left. greater than negative 15. So we put an open circle here. We go to the right. Now, because these inequalities are joined by the word and here, our solution is all x values that make both of them true, which would be this intersection here. In other words, our answer would be the following. So here's negative 15, here's negative 6, closed at negative 6, open at 15, and everything in between. Now, when working with this type of compound inequality, we didn't necessarily need to split. We could have started with this original chain of inequalities. So 15 less than or equal to 3 minus 2x is less than 33, and worked with all the parts at the same time. In other words, we can subtract 3 everywhere, which would give us 15 minus 3 is less than or equal to negative 2x, because the 3's would cancel in the middle. It's less than 33 minus 3. Or 12 is less than or equal to negative 2x, which is less than 30. And now we'll divide everything by negative 2. But remember, these have to flip. And this gives us negative 6 greater than or equal to x greater than negative 15, which we normally write in the other way, negative 15 less than x less than or equal to negative 6, which is our answer. All right, this is how we work with compound inequalities. Thank you, and we'll see you next time.